Okay, here's a matrix that's not in echelon form, and we're going to talk in this video about something called reduced echelon form. So what I'll do initially is very quickly run through the steps to put it into echelon form and then continue to show you what needs to happen to put it into reduced echelon form. So right away, I can see that the second row here, 0, 1, 0, is kind of in the perfect form already, in that the pivot, this is the second row here, so the pivot should be in the second position, and it is, and it's a 1. So if this were the identity matrix, this is what this row would look like, and that tells me that this row is really already perfect. The third row is nearly perfect in that there's a 1 in the first position, a 0 in the second position. There's a number in the third position, but we can probably get rid of that fairly quickly. The only problem with it is that because the uh, pivot or the potential pivot is in position 1 here, this should probably be row 1. So the first thing I'm going to do is reverse rows 1 and 2. And of course, I mean rows 1 and 3. I ended up, I said rows 1 and 2, but I meant rows 1 and 3. So this row here becomes row 3 down here, and row 3 becomes row 1. Now, because I have a 1 in my first row, first column, that becomes my pivot, and I can use elementary row operations to make sure everything below that is a 0. Well, the one immediately below it is already a 0, and I want the one below that also to be a 0. So I'm going to multiply row 1 by 2 and add it to row 3. Okay, so what I've done here is multiply each of the entries in this row by 2 and then add them in turn to each of the entries in this row. So I'll just grab one randomly. 2 times 3 is 6. 6 plus negative 7 is negative 1. And I've put that into the position of row 3. So now I have a pivot in row 1 and zeros below. The next thing to do to get it into echelon form is to get a pivot in column 2 and get zeros below that. So I'm going to take everything in row 2 here, focusing on column 2, but everything in row 2, multiply by negative 3 and add it to row 3. So I'll be multiplying everything in row 2 by negative 3 and adding it to row 3, and then I'm going to put that into row 3 as a new row 3. Okay, and notice as I do this that I'm operating on row 2, adding it to row 3, and putting it into row 3. So what changes is row 3 in this matrix is now different. It's new in this matrix. But even though I've used row 2, it doesn't change. Nothing in row 2 changes, and nothing in row 1 has changed. Okay, so now we have this matrix in echelon form. This is what we call echelon form. We have entries in each of the 3 pivot positions, and we have zeros below all of the pivots. So that's in echelon form. But the next thing we need to learn how to do is to put it into reduced echelon form. And that requires 2 additional ideas, really. It's going to be more than 2 steps in most cases, but you could think of them as steps. You could say, well, let's think of them as phases. Phase 1 is to get those pivots so that they're all 1s. And that just makes our work easier. And then the next phase is to get everything above each pivot to be a 0, as well as everything below each pivot a 0. So in this case, we actually have a pretty easy job ahead of us because I'm already in echelon form. Everything below my pivots is already a 0. And if I look at my pivots, everything above is also 0, except for this 3 right here. So this is the only one that I need to change into a 0. One of the other things that I can do very quickly with just scaling a row is turn this into a positive 1. So I think I'll do that first. I'll scale this row by multiplying it by negative 1. And in the next step, I'll multiply this row by negative 3 and add it to row 1. So I've scaled row 3, making everything in row 3 negative, and put that's my new row 3. If I multiply this entry, actually, let's go with this one first. If I multiply this entry in row 3 by negative 3, I get negative 3. When I add that to 3, I get 0. That's my new row 1. If I multiply this entry by negative 3, I get 300. And if I add that to this, I get 600, not 900. Let me fix that. So this is my matrix at this point, and this is what we call reduced echelon form. The thing that's so powerful about this form is that because these are all 1s, and because everything else is a zero, that combination of features, I can go back in here and reinterpret this matrix as a system. What I'll have by way of interpretation is, for this entry here, this is my x1. So I'll have x1, 1x1 plus 0x2 plus 0x3 equals 600. And then I'll have 0x1 plus 1x2 for the second row plus 0x3 equals 200. And 0x1 plus 0x2 plus 1x3 is negative 100. That's overkill as far as notation is concerned. All we really care about is the fact that when I sort of simplify this as much as I can see that x1 is 600 and x2, because the rest are zeros, right? The x2 is equal to 200 and x3 is equal to negative 100. So if the matrix is in this form, I can literally pick off the values that go, let's see, I'll use yellow for this one, x1 equals 600, x2 equals 200, and x3 equals negative 100. And that's really all I need to do once it's in that form. So having it in reduced echelon form is actually really very powerful. Most of your calculators will be able to do this for you. And I would like to encourage you to plug this into a calculator that does matrices. The TI-83, TI-84 series certainly do. I believe the TI-80, what's the new one? TI-86 maybe? I have an 85, but that's actually really, really old. It probably does it as well. Feel free to play around with these. Just keep in mind that as you take the quiz for this unit, because you're just learning how to do these, you will be asked to show your steps on paper. And so be able to do a problem like this where you reduce a matrix to echelon form and then to reduced echelon form. Be able to do that by hand. But do feel free to use your calculator to check your answers, and certainly feel free to use your calculator to help you kind of get to that point as you're learning how to do these. Just be able to do maybe one of these, at least one of these by hand on a quiz.